guys, Tom here, Permaculture Wilmington, coming at you today with a real life problem. I mean, it's serious, guys. What I've got is soil that has cyanobacteria. I believe this is Nostoc is the way you pronounce it. And you can see, here we go, some cyanobacteria. This is this green algae looking stuff, okay? This comes back to life as soon as it rains. If you water this, or it rains, it's coming back to life and it's going to keep growing. But this is its dormancy state. So you think it's dead because it's so crumbly and dry. You know, microbiology, they need moisture to live, right? Not this guy. It's just going into a dormancy state. So what we need to know about this is what kind of environment it lives in, okay? Because we know that chemistry, and I looked up how to get rid of this online. All the results I found were not biological, they were all chemistry. And we know that adding chemistry to our soil is wrong because microbiology controls the chemistry, not us. So if we take that out of the equation and we say, how do we handle this biologically? All right, we just need to find out what this organism likes, how it, you know, why is it here? Why is it growing? Because it's growing because it wants to be here. It likes this soil, this environment. We have created for it. So how do we get rid of that? So I looked it up, and this particular type of organism thrives in compacted soil, so it needs standing water, which means that there's a locking mechanism under the soil. It's compressed so much over the years, and from a log, there was a tree cut down, and a tree had been sitting here for several months, and that tree compacted the soil. So this is very, very hard soil. I've tried to put a fork in it over here just to aerate it, because we know that if it likes if this bacteria grows in compacted soil and thrives in where there's a standing water, which means there's compaction, which means there's anaerobic activity happening, then we know that anaerobes thrive in soil that doesn't have oxygen. So all we have to do is oxygenate it. But the problem is I've tried to put this pitchfork down, and that's as far as I can get it to go. So it's only going a couple inches, which means that there is literally a lock under the soil, a very hard layer. And we need to get through that, and then we just simply bend the fork back, and you can see that it's creating this crack. You see that crack? We're not disturbing the soil in terms of mixing up the layers. We're just adding oxygen. And when it rains, you know, this is going to go back together. But the point is that while we've got oxygen in the soil here, we're going to put compost tea, worm tea. This is going to allow the bacteria and the fungi and the nematodes and all the things that are in compost tea, all the soil food web, all these microbiology, these microbes. We're going to put the microbes into the holes, and they're going to be able to get down where there's moisture, and they're going to be able to sustain life because they need consistent moisture. So if we put them on the top, it's likely it's going to dry out. We'll have to apply often, you know, and it's going to take more time. But if we can get them in the soil, in the aeration cracks that we're creating, then we can get those guys down to where the bad guys are, and we can start this war. And if we put enough of the good guys, we're going to win. We're going to win, guys. This is biological. That's what this is. We are not using chemistry. We are using Mother Nature's way, which is basically putting organisms into an environment and sustaining the balance. When we put chemistry in here, we add to the anaerobic environment. We actually encourage our soil to get worse, and we need to stop doing that. I'm using this, but you really, this is a pitchfork, and I need something stronger to get down to the deeper layers to add more oxygen where this locking effect is happening. Where it just creates a crust underneath here. So I need to break that. And I'm going to do that with a garden fork. You can spend money on a broad fork, it costs a fortune, but a garden fork's only about 30 bucks. So that's the route I'm going. This area of my soil where the Nostoc algae is growing is actually not my responsibility. Guys, this is my yard. So I've got this beautiful Polyculture garden bed right next to the sidewalk. And I've also, I mean, this is a food forest. If you guys don't know what a food forest is, it means that we use the systems of nature. So I'm using the canopy to shade the earth on some things underneath it that I want to grow that are productive, that are food-bearing plants. And then we also have sun-loving food-bearing plants, which are the trees here. We've got, these are very productive Asian pear trees, and then right behind it over here, that is a plum tree. Beautiful 15-year-old Asian pear tree that produces about 10 gallons of pears a year for us. And this plum tree you see in front of you, we don't get a lot of plums off of it because of the fluctuating spring season that we have, where it goes from hot to cold really quick. But we do get some, and each are like a sweet treat every time we get one. We get a lot of good fruit off those each year. So, but this is a polyculture bed, and this is really beneficial because everything in here is edible. I mean, literally well, with the exception of the crepe myrtle here, that's not edible. And actually, hydrangeas have medicinal properties. You just have to know how to extract the compounds out of them and the qualities that we want for medicinal use. So, you know, just because plants aren't edible doesn't mean they're not beneficial to us biologically. But in terms of bug life, beneficial bugs, you know, drawing bees to your yard, drawing beneficial insects like ladybugs that really just love aphids. They eat aphid eggs and aphid larvae. So if we just create this system where it happens naturally with all these things that nature has designed to put together and to create a thriving, biologically active, healthy environment, then we can grow abundantly. I mean, I've got proof, guys. And this is not expensive. This is just oats. We grow mushrooms, so I took the oats from the mushrooms that we were growing after we grew the mushrooms, and it was basically spent substrate, which means we can't use it for mushroom growing anymore. They've already taken the nutrition out of it for them. But when they take nutrition out and they eat it, they break it down, and that becomes nutrition for other things, other plants. That's exactly what plants eat, is the enzymes, the amino acids that come from these organisms that break down soil and organic life. So the teeth of the forest, they call them. But the mycelium is the teeth of the forest, guys, if you've never heard that, because they are literally what breaks down all the organic matter in a forest. So, but in a flower bed and in a garden, we need a mix. I mean, we need a soil food web. We need bacteria, we need nematodes, we need it all. You know, we need the good guys and the bad guys. So we need a complete ecosystem, and that's what this is creating. I'm just putting oats in, and oats are super cheap. A big bag is like 14 bucks, and then you just boil it, or whatever means you want to make it so that it's not going to germinate. You can just throw it in a compost pile if you want to, really, because you're just adding nutrition. But I'd put it right in the soil when it was done growing mushrooms. And this is what happens, guys. You know, in terms of what plants feed bacteria, they feed them starch, they feed them sugars, and they feed them proteins. And when you break down what's in a grain of oat berries and wheat berries, you know, the actual grain that comes off the plant when it still has the husk on it, are considered to be berries. So these oat berries that we're using are highly nutritious, especially the husks, for microbiology, because that's where a lot of the nutrition is. So I'm basically feeding the biology with the same thing that plants do, using plant matter and using waste at that. That's something I've already used to grow food, and here we have it. Here we have success and nutrition put back into the soil, recycled for minimal cost. Look at the bounty here. I mean, this is chicory. So in terms of bounty, I mean, the size of the plant, I mean, this is a huge plant, right? And we've got a root underneath that is holding this up to stabilize it. Imagine how deep that root is. I mean, if you want to make chicory coffee, this is the plant that you want to take the root from, one that is this healthy. You know, I'd probably wait until before it flowers, because that's when the root has the most medicinal properties. So right now it's flowering. Technically, a couple weeks before it started shooting up these stringy stalks to grow flowers, that's the best time, because it's using energy from the root to do that stored energy. And we want to get the medicinal properties from it before the stored energy is exerted into flowering. So that is the best time, guys, if you really want to know. This is crimson clover. This is highly beneficial to a lot of animals in terms of fodder, and it's also beneficial to insects. I mean, the bees, we've never seen so many bees as we have with clover in our yard. And you think this is it, guys. Check this out. Look at this clover. Look at this. I'm talking insects. You want to get serious about beneficial and attracting butterflies, attracting bees? I mean, everything biologically is beneficial in its right place, don't get me wrong. But this is beauty, so it makes people that don't understand microbiology and don't understand how to take care of soil happy, and it makes people that love soil happy because it's a nitrogen fixer. So this is one of the healthiest things you can do for your soil, is add things like clover that regenerate the soil. You know, things like buckwheat, you've got dandelions, you've got radish, you've got, I mean, there's so many, all legumes, guys, beans, peas. These are all things that are regenerative to the soil that we can plant, that are still beautiful and still provide abundance for us to eat. We can still get food even though we're not spending money. And it's no secret, guys. No secret at all. It's just biology. It's knowledge. It's sharing knowledge. We can share this with each other, and we can teach people how to make this go away without chemicals and without doing things that are hurting our soil, our environment, our lives, the people around us, changing our disposition into negativity constantly because there's just so much killing and death. How do we get rid of this? Oh, we have to kill something. You know, you want to kill this to get rid of it. No, you don't. No, you don't. This is a beneficial organism, and not only that, it has medicinal properties for us. So we're just going to come in and put chemicals on it? That makes no sense. It's irrational. We need to think about this, guys. This is very irrational. What really gets me is that I pay for this. I pay for our HOA to maintain this. Does this look like somebody is actually caring about it? Does this look like anybody has actually put thought into doing anything to improve it? Guys, think about this. We can do this rationally, and it doesn't cost any money. We just have to teach people about biology and about how life works. We don't kill things, we improve things. That's our whole concept that we need to switch to, is that we need to be adding ammonium, which is organic matter, which is building and strengthening. So ammonium, compost, manure, you know, the grass especially. Grass was cultivated based on using animals to maintain it. And then the Industrial Revolution came around. We switched over to these big machines that compacted the soils as we rode our machines over them. And now we're sitting in a situation where nobody realizes that the animals that we were using to pull these tools were actually fertilizing the soil as they went along, teaching the soil and teaching the organisms in that soil to like that kind of fertility, which is bacteria dominated from the manure. So this right here is a perfect example of how we have completely lost touch with how to properly maintain an organism that we took out of the forest and cultivated. This needs to have manure put on it. This needs to be aerated, and then and maybe a little biological life to resustain the soil food web. And that's it. It's not rocket science, guys. It's biology. It's part of who we are. It's our bodies. Learning this teaches us more about ourselves than anything else I've ever done in my life. That's just my personal experience, guys. I'm very excited to share this with you. I hope you guys can tell. But I've already put several things out here. So I've already put some clover, and it didn't come up at all. And I watered it regularly. And I even put daikon radish. So there's still some daikon radish hanging out here. If you guys can see in between, look, it's dwindling. I mean, it's here. It's still here, but it's dwindling. So hopefully adding a little aeration is going to help. But right here, see the daikon radish is coming up, and it should be completely just growing abundantly here. It should be prolific. Because if I take you in my front yard and show you, I planted daikon radish at the same exact time. So come check this out. You're gonna love this. This is amazing in comparison. This is the clover I planted right before I put clover seed out here. And I watered it at the same time, same intervals when I was the first week or two after I planted it. And you see how high this is. I mean, this is beautiful red clover. This is edible. There's some daikon radish mixed in. And these are the size of the daikon radish that should be growing out here right now if this soil wasn't anaerobic. But it's in such a state of poor health with the anaerobic activity that nothing's growing. It's the compaction and the anaerobes. So we just need to switch it to aerobes, and by adding oxygen, you know, and switch it, you know, that's going to get the aerobes going. But then we need to reintroduce the organisms that were pushed out. So we need to put the microbes that have been off balanced from improper care of this soil, you know, and that's how we fix it. So this is healthy clover, and in soil that really wasn't healthy. I mean, this was grass, and all I actually tilled up the grass. So guys, this is what soil looks like when it's not compacted and it's unhealthy. You can still grow things like clover. That's the whole point in nature. Plants that are meant to regenerate the soil, so they will grow in soil that's not fertile because they have bacteria on their roots that pull nutrients that they need out of the air, out of the interstitial space in the soil. But if there's no air in the soil, then these organisms can't get that air, can't get the nutrients from it, because there's no air. That's how they exist, is to pull the nitrogen from the atmosphere in the soil. So if we compact it and take the air out, this is what happens. That's the easiest way to explain it. But this is not fertile soil. This is still sand. Guys, you see this? This is sand. This is horrible soil in terms of growing vegetables and growing things that really like ammonium. So ammonium is the trick, and ammonium is compost after it's been composted. So completely composted organic material, vegetation scraps, or kitchen scraps, vegetation from your garden. We break that down through composting. Thermal is better, but I mean, really, if we can just get everybody to compost, the world would be a better place in general. So, but look at how sandy and dry this is, you know, and we can grow beautiful edible plants, and this is healthy. You know, we can grow radish. Radish is super healthy. And we can cook radish if we don't like the radish flavor to get that heat, that radish texture, flavor out of it. So guys, this is a better way. Now check out the radish that I planted in front of the house on the swale. So if you guys watch the video about making mushrooms, building a swale in front of the house, we have a wine cap swale here, and then I took the dirt out. And it was dirt, it's not soil. I took the dirt out from underneath the grass, the very poor grass that was growing, and I just put it on the front of the mound and filled the swale with wood chips and layered it and put mycelium in here. So this is going to hopefully grow mushrooms, especially in the shady spots when it rains. Now this is daikon radish, and it is growing beautifully right now. I just put some worm tea on it last night. So pretty soon, I mean, it's got some yellowing, but again, this is dirt, and this is growing. I mean, some of them, look at this is getting to maturity, and it's better than it was out on the median next to the road. Okay, and that's the whole point. Is I don't want to show you that this is doing so well, that, you know, this is great soil, and this is regenerating soil. This looks bad for a reason. This looks bad because it's bringing this back to health, but we have a plant that is growing in this soil, and this is reaching the next stage of its maturity. So this is a very good thing, guys. So yes, and next year I'll be able to grow something in this soil and have it come up and thrive from the very start, because I did this year. Okay, this is regenerative planting. So we're planting this year to have a better year next year. That's how that works. Call it a cover crop, call it whatever you want to, but we're making the soil better. We're putting organics into the soil. We're putting things that put nutrients into the soil. We're growing things to regenerate soil. There is some clover in here, and again, this is the size of the clover that should be out front. I mean, because this is also poor soil, or dirt actually. It was dirt, now it's soil, because I inoculated it with worm tea. So this is legitimate soil here, because it does have microbiology, and it does have moisture in it. You can see it's a little dark right here. I just watered it last night and then put worm tea on it in the dark, and it's just, you know, it's coming back to life, guys. So we are doing this, and it's not costing a lot of money. Look at that. Oh, that's not a ladybug. That's one of those ones that bite. No, it's like a Japanese, I forget the name of it, but that is not a ladybug, guys. That's an orange one. Ladybugs are red. So just keep that in mind. But everything is beneficial. So anything that's a bug in my yard, I'm happy to have it for whatever reason. And even caterpillars, I know I'm not a big fan of caterpillars, but caterpillars eat our vegetation that we want to eat, like our cabbages and our squash. But at the same time, they play a role as well. So guys, this is Tom, Permaculture Wilmington, regenerative planting. I hope you guys are growing abundantly and living regeneratively. Have a great day. Bye-bye.